Okay, so sorry for interruption. I just wasted my 1 hour because I have the time. I was supposed to start this stream at 4 p.m. and it's just 5:10. So I just wasted. Okay, why I'm canceling it? I just wasted 1 hour and I just only I have done only one question, that is the daily question. That was pretty easy. Okay, let's start with, and we are not. I'm not explaining too much. Just I'm solving the question. A little high. This is the so nums dot back minus, it will be the maximum possible distance between any two stalls. Okay, so it will be the high. So this is the normal back normal. We should use add r, and not r is less than n. And what I'm doing, I have to calculate the mid, that will be the L plus and r minus L by 2. And here we have mid, and we have to compute that is it possible to arrange the cow with a distance of this, which is with a minimum distance of this. If it is possible, then we are going to arrange the cows if it is possible, and if it is not possible, then we will kind of break. So int if cows we have 0. So if we'll see that okay, we see let cows are greater than equals to k, then we are going to increase. Okay, we are going to increase our this distance, and if it is not possible, then we are going to decrease our distance. Okay, if it is possible, that we are going to increase our distance mid, and if it is not possible, then we are going to decrease our. Okay, so we will okay, now we have to find cows. So I'm going to running a loop for int I 0 and I is less than n, and I will be plus plus. I think I have not used num, so nums as this is used only here, but for every iteration it function will be called calculated. So instead just give the 4 byte, and we are going to use here n. So what we are going to here is I have to place the cows. If the last cow is at, just place a cow 1. We have placed cow 1 at end brief the previous cow, and previous cow at nums of 0. Okay, now I have to go with, I can use the binary search. No, binary search should not be appropriate. Like if my nums of I is like if I have placed my cow at 1 and of k is 3, then I can only place at either at 4 or 3. Okay, 4 or 3. So 4 or greater than 4. If nums of I is greater than equals to the prev plus nums of prev plus our mid. Okay, if it is greater than equals to, then I can place our cow here. So I will increase my cow, and I will prev that will be I, else I just continuing my loop. And if my cow plus plus, if my plus plus cow, okay, I'll just saving my complexity. If my plus plus cow it equals to k, then I'm going to break that loop. Okay, the control will transfer here, it will check this condition will run. We will increase our middle, we will increase our this value, whatever it is. Okay, let us run our code. It should accept. There's a runtime error, and there is a while loop, infinite loop. Let me just check what is the loop here. L is 1, r is this, and return L. When I'm going to L is less than r, and we have to do when we have cow will be L, and I just place my cow, okay, 2. I have to place the cow at 1. I should start with 1, not 0, because I have placed my cow at 0. Prev, that is nums 0. I'll start my I, that will be 1. I is less than n. And okay, if my nums of I, that will be the value at that particular index, it is greater than nums of prev and plus mid. Mid is the interval. If it is equal, then if k cow is plus to k, then it will break and it will out of the loop. And if cow is greater than equals to k, the we have assigned the number of cows, and then I'll have to increase our weight L, that will be equal to mid plus 1, and there will be R, that will be mid minus 1. I think this kind of issue. There is a runtime error due to this. It is a runtime error. How I can't even print? What's the point? If cow is greater than equals to k, then I'm going to L, that will be mid, and if and L is less than, L will be 1. Nums I have sorted. I have reverse sorted. No, I have sorted the array. Nums dot back will be greater element and nums of 0 will be smaller element. Okay, fine. Nums dot back will be greater element and nums of I will be smaller, and the distance will be, there is 9 minus 1, that is 8. Then I for L, and in mid, okay, that will be mid, that will be L, R minus L divided by 2. Okay, it is perfectly fine. Cow 1 previous, that will be nums of 0. Okay, then I'll run my loop with I, that will be 1, and I is less than, and if nums of I is greater than equals to nums of prev is kind of index. Prev should be index there. I am just going prev, that will be 0. Prev is an index. So if nums of I is greater than equals to nums of prev plus mid, okay, if this condition will like we can place a cow there, so I'm just okay, let's not do this. I don't think it is making a problem. And my previous index, I have just placed my cow there, it will be I. I don't know why it is, your program took more time than expected. Let me just, if cow equals to k, you have to return the mid. I know it is not accurate, I am just compromising my accuracy. Okay, your output is 2 expected output 3. Okay, we can go for more. Okay, it's just having an infinite loop. 1 2 4 8 9. Low is there, low is 0, low is 1, basically low is 1, and high is kind of 8, and the value will be mid value at first will be 4. We'll say it is possible to have assigned, so I have assigned a cow at 1, then the value should be at minimum distance should be 4, so it should be at 5 distance. So not that here we have 5, we can assign there. Okay, I can assign there 5, then there will be okay, I can assign there, and there will be I. So the cow is lesser than, okay, let me just print the middle value every time it executing. It should, so first is 4, okay, first is 4, You see, first is 4. After 4, like we cannot have the distance is 4, so we are going to 4 minus 1, so we are going for 3. L is 1 and R is going for 3, and now we are just having mid that will be equals to 2. Okay, for that mid we are just going to allocate trying to allocate the stalls for each cow. So first cow will be at 1. Other cow, is it possible to have 2? No. Is it possible to add 4? Yes, it is possible to add 4, so we can assign 2 for second cow there. It is possible to have at 8? Yes, it is possible. Now my cows are greater than equals to uh, equals to 2. It is possible, then I should break. Okay, mid 2 it is possible, and the cow will be k, so this condition will satisfy like it for 2 it is working. For 2 it is working, so what I'll do is I'll go for more than 1. I'll go for more than 1, that will be 2. I'll go for more than 1, that will be 2. I have 2 as middle, and I'll have 3 as maximum. L and R, the middle value will be 3. Middle should be 3. No, 3 plus 2 5 divided by 2 will be 2. Okay, middle is 2. When I got the middle 2, I'll just stuck for the same condition. When I am going to just stuck for the same condition, L, this is the case where yesterday I was talking about, so I have to optimize it by using L to L plus 1. Okay, L to L plus 1. Okay, if cow is equals to this particular value, you should go for L is equals to L plus 1. Okay, but here is the condition, L should be our answer. So instead of going this boundary, I have to shrink for that boundary. 2 is working well. Okay, my 2 is working well. Okay, I can do a thing. It's like we have an answer that will be 0, and we will return that answer, and L will be mid plus 1, and answer will be maximum of answer comma L. Let us try this. Hyperspeed execution model. I think internet is not working, or what? Internet is great. This is Airtel 5G network. I was using Jio 3, 4, 5 days before. It is performing worse, and I just recharged in Jio, and I got scammed. Okay, it is not working. I have to refresh it, and I have to compilation error, return answer, and answer I have defined here. So I have to define outside this loop. It is not accessible there, so now everything should work fine. I have expected 3. I have, your output is 4. Now I am getting 4. Why I am getting 4? 4 2. Why? Now we have to do this, because L should be equals to R now. Okay, now we can miss this. We can submit it now. That's the case where I am confusing about. If I'm going for L less than R, then there is a case that I was stuck in just a while before. How to handle this case? As I going for L, that is mid plus 1, if it is possible to have, if it is not possible to have, just go for mid minus 1. If it is possible to have, just go for mid plus 1. My algorithm is correct, but there is some edge cases at the converging point. My there is a flow between plus 1 and plus 2. I have to at the first time when I was doing this, the same problem I had encountered, but at that time I just skipped that part. But now I have to purely understood the concept. I have to understand the concept behind this. So we have mid, that is L. Okay, it is working well. Problem is here, how we are approaching this value. If I go for L, and the value for this input will be exactly same as the expected. Okay, it is not same because I have used this. देखो, value is same, but for that test case, when my value is not able to converge for the I have to shrink the boundary. I think I have to shrink the boundary again. For this space I have to shrink the boundary again. No, I can't do this. It will be a blunder. I can't shrink the boundary. Whenever I am just stucking on this case, I cannot use mid plus 1 because mid is working well. As mid is working well, so I can't do mid plus 1. I can't do mid plus 1. I cannot do mid plus 1. Okay. Yaar, what will be the, we have these test cases that will be 0 and 1, 0 and 1. When I going for here and there, that will be, for example, 2 and 3. My answer is 3, but it will check for 2 as well. It is not moving further. Why it is not moving further? If L and mid are equal, okay, now there is a case L is equals to mid, it is working well. When I am going for L equals to mid plus 1, when I am going to, if L is equals to mid, if L is equals to mid, just go for mid plus 1. Okay. I have to, if L is equals to mid, just go mid plus 1 and continue. Okay, the case was, earlier the case was 1 2, okay, 1 2 4 8 9, 1 2 4 8 9, and the value was 3. Now if it work, then it is not working. Same, it is not working. Why? I don't know. It should work now. If L is equals to mid, it is in loop. Mid will be same, that will be equals to L. Now from here, L is equals to mid. I think now there is a loop inside this. Int I is less than end, I plus plus, nums of I pref, it should break the code. continue, and still runtime error means everything is fine at top. Just I have to debug it. I don't know what I am just doing. But wait, if L is equals to mid, okay, L is equals to mid, and L is working, and what if your R, that R will not work, if you just shrink the window. My edge case is here it is working and here it is not working, but every time it got stuck there. Now I am telling that just increase L to mid plus 1. My L will go there, and for that process the condition will not satisfy. Okay, for the process the condition will not satisfy, or L will be equals to R. The algorithm will not check, even the algorithm will not check for that condition, as L is equals to R. Then what will we do? As it will not check, here it is L and R, the mid is this, it is working for this fine. For R, if I go for R is mid, if I go for R is equals to mid, then I know at R it will not work. Okay, then I know for R it will not work. What if it will work for R? It will not work for R, so algorithm will converge on R. So we are going to return that R or L, whatever you want. Now we are going for algorithm will not work at R. Okay, now my expected answer is 4. Count 4 2 3 3 3 3. Listen, we have a 3, again we have a mid 3, so every time algorithm is converged at 3. So whenever your algorithm is converged at 3, mid minus 1, whenever your algorithm is converged at 3, 3 3 3 3 3 3, just reduce the R. Okay, what was the summation? And can we just get the test case? Just get the test case? Okay, I think we are not able to go for test cases. Let us submit this. It's 152 1517 and k की value is 2. Whenever we have k is 2, just return the 17 minus 1. But why my algorithm is not working? 1517, algorithm is going for 1 and the maximum will be 16. Now it should converge at R. and we have L there. Okay. R should be weekend R press. I think it should work now because there is a logic behind it. It is working. It is working. I know it will work, and I know the concept, because here I am assuming that my converse will not happen at R will be the upper bound, because if listen, mid, if the element is not satisfy at mid and I am just assigning R as this mid, that means my algorithm will never converge to R. But so to ensure this, I should have add the extra value. That is not possible. That is why the maximum value, the possibility of value is 16, but I am adding extra because my algorithm will never converge at the upper bound. Okay, that's why I'm writing this. Oh, okay, is there any possible to like make this code cleaner? Let me just check, because I need to strong this concept. Like नॉट, मैं इससे ऐसे नहीं पूछ रहा हूँ, मैं इससे अपना एरर वाला सिस्टम से ही पूछ रहा हूँ कि मैं ये सब नहीं कर रहा, मैं ये कर रहा हूँ बस मिड -1. ओके, मैं कहता हूँ इसमें एरर हाउ टू फिक्स. Okay, we can go for next question, and it is already optimal approach, that is binary search, and go for book allocation problem. So this is opening a random site, so go for book allocation problem. We allocate minimum pages and we have to solve this. Today we are more like we are very least productive. I just have solved only one question in this driver sheet in just 2 hours. I just wasted, so I have to. So here we have the fixes and wrong binary search pattern. The pattern is wrong. It can lead to infinite loop. We know that it is an infinite loop. Incorrect return value. So it is going for less than or equals to R. Okay, and there is an answer that will take the minimum. So L will be mid +1, try larger distance. R will be mid -1, try. Okay, it is going for this. I think I had tried this, but whatever it is. So there are two patterns in some question, like the question before this. In all these question we are using less than, and in this particular book allocation or aggressive chaos problem we have to use equals to. So let us see. I have submitted this. Yes, I have submitted this before. Let us see. Given an array of integer where each element array represent the number of pages in ith book. Okay, the number of pages in ith book. You also have an integer array representing the number of students you tasked to allocate the books to each. I have to, there are books and there are number of pages in each books and there are k students. Okay, we have, our task is to allocate the books to students. Each student receive at least one book, means one student should get at least one book. Okay, at least one, at most any of the book, and each student is assigned a continuous sequence book. Okay, you can't just you cannot assign the book in subset order. You have to assign the book in sequence order. Like if the student 1 will get 12, 34 or 67, student 2 can get like 34, 67 and 90. None of the student can get a book with 12 page and 90 page. Okay, no book assigned. Okay, it is, the objective is to minimize the maximum number of pages assigned to, the maximum number of pages that is assigned to any student. Okay, in this kind of partition The maximum number of pages is this. We have to minimize this. Okay, got it. How do we do this? We know the topic, so we are going for binary search, as we already know. And the complexity is 10 to the power 6. We can't solve it in n square. We have to solve it in n log n. And there is not any kind of priority base, so we have to use the binary search. Divide and conquer searching. So first solve this binary search, and then we'll see how we can solve it in divide and conquer. 12, 14, 16. So we know that binary search will be applied in this question. How? So we just define the pages. We have to define the pages. We have total number of pages. We can allocate the minimum number of pages is 1, and we can allocate the minimum number of pages to every student is maximum 90. It will be 90. It is the lower bound. 90 is the lower bound. Okay, the maximum page 90, and the upper bound will be upper bound will be let's say total sum of this book for sure. We are not adding the extra loop for iterating the exact upper bound. So we will go for, because we have to minimize the pages, so it will work. So the third combination had to minimize pages. So either we can get a student 1 this book, and all the other books to other student 2, this to a student, all the other get will this 2, this for a student, all the other will get this. So listen, do we require some prefix sum? How could we found the maximum at every position? I'm telling it is possible to have maximum 113. Let us see, it is possible to not 113. The sum is tick tick tick. No, maximum I can allow to this. It is 113. Okay, maximum I can allow to is this is okay. Maximum number of pages, if I do the partition in this way, we are getting maximum pages. फाइनली सर्च हम पेजों पे लगा देंगे, कोई दिक्कत नहीं है, नो इशू. बट व्हाट अबाउट हाउ टू कैलकुलेट दिस? इट इज द मेन प्रॉब्लम. Accuracy of this question is around 35%. Let's start the timer. I have done this question before, still I am able to figure it out in 35 minutes or not. Let us see. So we have 12, 34, 67 and 90. Main part is this, how do we allocate the page. Okay, I have given this page to this and the other page to this. The sum will be, I'll assign sum will be, I cannot assign all these pages to a thing. So all the possible sum, we have to find all the possible sum values, and it should be like 113 pages. Let us see all the possible pages 113. So I have to found the prefix sum. I know it. If I am able to get 113 pages, we can see if I am able to get. Okay, so we let us say we have a prefix sum. Let us say we have a prefix sum 0, 12, 0, 12 and 4 to 6, 46, and first three element the sum is 113, and whole full sum of this is 191 plus 10, 201 and 2, 203. We have this. Now for any index I, L to R, the sum will be pre of R plus 1 minus pre of L, that will be 113. Okay, so we have to find the L value. So 113 minus pre of R plus 1, that will be pre of, we have to find the exact limit if it is possible. If it is not possible, if let us say if it is not possible, if it is not possible to assign, let us say if it is not possible to assign a certain pages, so we should go for left or we should go for right? How do we figure out this? For example, I have 60 pages. I am not able to, for example, my lower bound is 90. Let's say 90 pages. I am assigning the 90 pages. So it is possible to assign the 90 pages. I have to do copy paste. 12, 34, 67, 90, and I do have k is 2. So is it possible to have? I have only 10 minutes to think the approach, like we all have the time in an interview. So 67, 90, and the value of k is 2. So what do we have to do? We have to do the binary search. And how we are going to do binary search? Let us see. K value is 2. Okay, k value is 2. So there are 2 children to assign. What if k value is like greater than 2 or 5 children? If there are 5 children, okay, I know where to use 5. Okay, 12 is there, 34 is there, 67 is there, and 90 is there. Is there, 34 is there, 67 is there, and 90 is there. So k की value is 2. So prefix sum, I got prefix sum 12, 34, 46, 113 and 203. Now for example, my minimum is 20 and my maximum is 4 sum. For example, I get 113, I'll get 113. So it is possible to have in this bound. So I'll found the index, the most precious, the most index. The pages could be 0 if the pages array of size is okay, it is greater than 1, means each value will be unique. Okay, कम से कम ये तो मिला. अगर हमें यूनिक वैल्यू मिल रही है तो वी कैन यूज मैप फॉर स्टोरिंग द इंडेक्सेस ऑफ ईच प्रीफिक्स सम. If I am going here and I'll say will okay, I want 113. Okay, prefix of r it will be prefix of L, it will be 113. Okay, it is minus, so prefix of L will be prefix of R plus 1, that is 113 minus 113, that is 0. Okay, I am getting it, and it is inside the range, the maximum range. It is inside the maximum range. Okay, it is inside the maximum range, and I'll give all the student to all the students should also get the minimum value than this. Like if I got 13, any other student is getting okay. If I got listen, if I got how much time does it left? 3 minutes left for thinking, to think about allocate maximum resources. I'm not able to gather my thought together to solve this problem, but binary search, there will be prefix, there will be a map, and I have to just use 0, 12, 16, 113. For every step I'll just get the number of answer. Okay, these are my pages. Is it minimum or not? Is it minimum or not? Okay, I got it. If it is the minimum index, I should go for, okay, I got it. We will not require this. If I am talking about 114, is it possible to allocate 2 students? So I will allocate the books. I'll allocate the books that is less than 14. Like I will allocate the books 13. Got it. I got it. So before 8 minutes I got it. Let us see. Int L will be I need to get the sum. I don't need to get the sum. And what R will be the sum of these things. Okay, so L will be 0, and int H will be, that will be R, it also will be 0, and we have to for int address of I in nums, say it is in nums, and we have to add R plus equals to I, and L will be maximum of L plus, it could not be possible to assign a book individual if we are going to assign minimum L comma I. Now we are going for I, L is less than R, and I am going for return this L. Now I have to calculate int mid, that will be L plus R minus L divided by 2, and I have to check this how many minimum student required. Int minimum required, that will be 0. If my minimum required, okay, k की वैल्यू 2 है. If my minimum required is if my k is less than, k will be always less than, we have no condition for k. If it is not possible, so when it will not possible, if k is like int n will be nums dot size. If k is greater than n, then I have to return -1. It is not possible. So minimum required, if my minimum student required minimum student required, at least मुझे इसके लिए like 4 3 I got, एक बच्चा चाहिए मुझे बस 13 पेज के लिए. ओके, आई जस्ट नीड बाकी मैं उसके बाद इनमें फिगर आउट भी कर सकता हूँ. Okay, if my minimum required is less than equals to k, okay, minimum requirement मेरी इतने पेजों के लिए, that minimum requirement 2 है. फॉर एग्जाम्पल मिनिमम रिक्वायरमेंट ही मेरी 4 आ रही है, तो 4 बच्चे ऐसे होंगे, मतलब उनका सम, ठीक है, तो 4 बच्चे ऐसे होंगे, 4 बच्चे से ज़्यादा बच्चे की रिक्वायरमेंट है, लाइक k is 3 and I am going for 3 student, there is a partition possible which we can have. If I am going to reduce for 3, then partition, it will work. I am not I might be not able to explain to you why it will work, but it will work. Just take copy and pen and paper and think about it, why it will work. Just minimum requirement for these pages. Now if the pages is greater than k, then to adjust we to if the minimum requirement is greater than k, and if I am going to decrease the k to this k, so we have to increase the number of pages, and we are going to increase the number of pages, but our task is to minimize it. Okay, so if it is possible, then we can minimize more, then our r will be mid, and our l will be mid. And how to take this? For int minimum required is 0, int address of I in nums, okay, int pages, that is 0, and pages pages plus equals to I, okay. If pages plus I is lesser than, if pages plus I is lesser than equals to that mid, I will add that pages plus equals to I, else I'll do pages to be 0 and the minimum requirement will be plus plus. Let us see it will work or not. Your output is 90. How it is possible for now 90? Like for 90, 30 to 32, the minimum requirement is, for 90 the minimum requirement is 1, okay. Pages will be 0, minimum requirement plus plus, pages plus equals to I. Initially pages is 0, minimum requirement is 1, so I'll add this. For this I have to remove this, so minimum requirement is 2, so my pages will 0, not my pages will be 0, my pages will be I, and I have to do things. There's a infinite loop as we were doing in the last time. Now I have to do certain things. If my mid, okay, if it is not possible, I have to minimize it. Okay, I have to minimize it. So if it is possible, then I am going to minimize it. Okay, if it is possible, if it is working at mid, I am going for mid, and if it is not working for mid, now it is working fine. If it is working for mid, I'll just, okay, it will not work because my L is working. It will work, I think it will work, it should work. Okay, it is working. Listen, your algorithm, if it is binary search and you are writing L is less than equals to R, and if your L is incrementing, okay, if your L is mid plus 1, then your algorithm will never stuck into an infinite loop. The problem will there if inside the while, if there is L is less than R, not equal equality is not considered here. And inside your while loop, in your while discarding or accepting a particular search space, you are either discarding left part or right part. If you are going for this L as mid and R as a mid -1, then there will be a chance. For example, take L as 3 for adjacent cases, L as 3 and R as 4, it will always, and your L is working fine and at your current and you are at a current index L, and for L3 it is value is acceptable, then you try to find the mid. Every time mid is L, and every time L will become 3, R will become 3, R is like as it is 4. Every time mid will be same, L will be same and R will be same, so you will be in a infinite loop. To make that, like to escape from this condition, you have to move your left pointer. So as I does in the last, as I have done in the last solution, you have to do think, or either you can use the equality condition, and for equality condition you have to use the extra variable that will keep the maximum or minimum, whatever you are looking for. So this is the case, or I got it now. If you are here and if your algorithm is doing this, then there will be no error and there will be error. Okay, now we are going for split array largest sum. We have done the book allocation, we have done the aggressive cow, we have done the kicks. Okay, now split array. Listen, it took me to think about 8 minutes to the approach, and it has two contexts. I have already solved this problem. Okay, second, I knew the topic, that is binary search. Still I am not able to figure it out initially. So and here there is no pressure on me. So just think about if you are sitting in an interviewer cell, placement cell, and your interviewer asks to you such kind of questions where you are not aware about the topic and where you have not seen that question before, and you have to solve it in 8 to 10. You have to think it in the approach in about 10 minutes. It is quite difficult, it is too difficult. And if the question, if you know the topic, you can put all the energy in that direction only, then it is quite easy. But yeah, it's difficult. The split array largest sum, it's been 1 hour and it's 6. Let's see one more problem and we will bind up this split array largest sum. It is a hard problem. Given an array nums and an integer k, split nums into k non-empty sub arrays such as the largest non-empty. Okay, it is just kind of book allocation problem. If I have pasted the same, I have to minimize the largest sum. Okay, my like, okay, I just pasting my book allocation problem here and it will increase my number of questions. The logic is this. Let us see it is working or not. It is working fine and it will work fine. Just take few seconds. Copy and paste. This is exactly what a book allocation problem which I have just solved. So okay, as let us we can see now one more problem. Driver sheet. Painter's partition. painters partition problem, GFG practice. Okay, given an array where each element denotes the length of board, okay, and k unit represent the painters available. Each painter takes 1 unit time to paint 1 unit of length. This is the length of board, this is the length of board, and each painter took 1 unit takes 1 unit to paint 1 unit. For example, I have to paint this, it takes 5 unit. Determine the minimum amount of time required to paint all the boards. Under the constraint, we have to paint all the boards. We have 3 painters, and we have to require the minimum amount of time required, and each painter can paint only a contiguous sequence of boards. Okay, uh, if the painter here, it can paint this sequence. If the paint here, it can paint this sequence. If the paint here, so we have to divide this board into a contiguous sequence, just like we do in a book allocation, such that the time is 15, the time is 60, 50, and the time is 15. The overall time will be 35. Overall time will be 35. So I have to minimize that overall time. So I was minimizing the, I don't know, it's just like the same problem. We have to minimizing where there we were minimizing the pages. Here we have to minimize the these times. Guys, I am not just solving any question for now. Okay, this is exactly same problem but with different statement. Okay, now I'm going, I'm leaving. I think we should done the problem tomorrow. And how many problem I have done today is, let's count. Striver DSA sheet, and these are binary search, and I think so I have done 1, 2, 3, 4 and 5 problems. Among 5, the 2 problems are the 3 problems are exactly same. So -3 plus 1 minus 2, so I have just 3 question. I did just 3 question. Okay, see you tomorrow. Today is